All right, guys, in this video, we're going to go over the parent function for the graph of cosecant. So if you recall, using your unit circle, the graph of y equals sine of x, and your knowledge that cosecant of x is equal to 1 over sine of x. Let's underline that here, or I'll box this in. Cosecant is the reciprocal of sine. Graph y equals cosecant x in the interval negative 2 pi to 2 pi, inclusive. Then identify the domain, range, asymptotes, period, and if the function is even or odd. All right, so what we have here, we have the graph of cosine plotted, okay? And if we recall from the unit circle, all right, let's just do a quick sketch. One, 0, 0, 1. Negative 1, 0. And then 0, negative 1. And this is at 0 radians. Let me zoom in a little bit. So this is at 0 radians here. This is at pi over 2 radians, pi radians, and then technically 0 and 2 pi, right, if we go all the way around. And then this is at 3 pi over 2 radians. All right. So our kind of key points to look at for cosecant are going to be at these quadrant values, okay? So at 0, remember sine, let me put it in red actually. Sine is our y values, okay? The y values of the coordinates, okay? So 1 over 0 is going to be our cosecant value at 0. So therefore, technically at cosecant of 0, we're going to have 1 over 0 is undefined. At pi over 2, it would be the same as 1 over sine of pi over 2, which is going to be 1. And I'll write these down so that way you can kind of see where we're getting these values from. So I just made a little table of values here, right? If you subbed in 0, it would be undefined. At pi over 2, we would be at 1. So this would technically be here. 1 pi over 2, 1 would be a shared coordinate. And then if we look at pi, it would again be 1 over 0, which would result again in an undefined value. So we would have a vertical asymptote here at pi as well. We'll do the same thing at 3 pi over 2. Sub that in. If we sub in 3 pi over 2, we would have 1 over negative 1, which is negative 1. And then if we go back to 2 pi would also be undefined because it's the same as 0, the x value at 0. Okay. Now, what's happening in between? Well, if we take the reciprocal of, let's say, for example, pi over 6, right? So it's about 0.5. So instead of it being at a half, the reciprocal value would be at 2, right? So we could say 2 here. And we can do the same thing at 5 pi over 6. Okay, and I'll put a note here. X cosecant of x. So if we did pi over 6 1 over a half, which is 2. Okay, so that's what that value is. Let's put it in green. And we can do the same thing at 5 pi over 6. Okay, and then if we go in quadrant 3, let's say we had, therefore it would be 7 pi over 6. It would be 1 over negative a half, which is going to be negative 2, and I'll plot that point again in green. 7 pi over 6. So this is about 21 divided by 6, so it's about 3.5. So it's a little bit past pi here. And we know that in quadrant 4, it'll also be negative. So that's why if we were to flip it, we would have that value also to be at negative 2. Okay, and we'll put negative 2 here. Okay, so this here, these from 0 to 2 pi, like these two, the upward facing parabola and the downward facing parabola is actually one period of cosecant. Okay, and we could do the same on the other side. So if we were to graph from 0 to negative pi, we would have this asymptote at negative pi and at negative 2 pi. We would have a relative minimum here at negative 3 pi over 2, 1. And then we would essentially just reverse the direction of the parabola. I call it reversing the hump. So if it's downward facing in between these asymptotes, it'll become upward facing. And then from negative pi to 0, because it's an upward facing parabola, it'll now become a downward facing parabola for the cosecant because it's the reciprocal function. All right. So let's go and look at the characteristics of cosecant. So our domain for cosecant, it's real numbers except for multiples of pi. 0, 1 pi, 2 pi, 3 pi, it'll just keep going. So that's our parent function's domain. And then our range, all right, we have a break in the graph. It's really only the graph, this graph in blue, these two parabolas. So our range is technically, if we look on each end, it's from positive, and this goes up to infinity, but then it stops at 1. This goes down to negative infinity, but the maximum point here is negative 1. So we're going to go least to greatest. So technically remember our default is negative infinity to infinity, but it's not negative infinity to infinity for this function. It's negative infinity to negative 1 because of the relative max there. And then I'm going to put a closed bracket because it can equal it. And then there's a jump. It goes from 1 to infinity. Closed at 1, open at infinity. All right. Our asymptotes occur every multiple of pi, and they are vertical. So we're going to write vertical asymptotes at every n pi units. And the period is still 2 pi. It still takes 2 pi units to complete one full cycle of cosecant. And similar to sine, because it's based off of the graph of sine, and sine is odd, cosecant will also have odd symmetry. All right, there's symmetry about the origin, symmetry about the origin. And probably the most telling coordinate here would be, let's do this here, pi over 2 1. And then because it's symmetric about the origin, the other coordinate here would be negative pi over 2, negative 1, which is that there. Okay, so we have our verification that there's going to be odd symmetry in this graph. All right, so this is the parent function for cosecant.